Hello, hi everyone. Okay, so welcome to this exam build-up tutorial. So today we have a science, or rather physics to be specific, question, and this video is suitable for people that are doing pure physics as well as science. Okay, now the focus for today, we're going to look at the mass, volume, weight, also volume of the substance. So, talking about this, you will discover that we're going to solve a lot of questions, of which I call miscellaneous questions. So, in these videos, we're going to be doing questions of different kinds, but on this topic. So, make sure you stay glued to each and every episode of these videos so that we can keep learning together. Right. So without wasting so much of our time, let's quickly see how best we can provide solutions to this problem. Right. So this is the first question, and it says a student measures the mass and the volume of 4 samples of rock A, B, C, and D. The results are shown in this figure here. Right. So we have volume, also have mass here, then we have rock A, rock B, rock C, and rock D. And these are the masses for this one. This one is the mass for B, mass for C, mass for D, and then the volumes are in, of course, cubic centimeters, and the volume for A is 22, volume for B is 44, volume for C is 80, and we have the volume for D, which is 979. Right. So let's quickly see what this examiner was asking us to do. All right. So you will realize that the first question asks us to describe in detail how a measuring cylinder, you know that that's an apparatus that is used to measure volume, of course, is used to find the volume of rock A. So we're looking at it, this specific rock. So why are they saying rock A? Because it has the smallest measurements in terms of mass and also volume, right? So let's explain in details. First, to be able to score 2 marks. All right. So how are we going to do that? Okay. So one, you understand to say the cylinder. Let me just draw this one. So as you explain in details, you can also include drawings in your illustration. So this is the cylinder that you have, and of course it has the calibrations here. These are always, sometimes in, most of the times they'll be in mils, or they can be in cubic centimeters. So this is that. Then you have a rock here, which is going to be rock A, and this is your cylinder. Okay. Then you pour a volume of water here, and then this rock is tied to a cotton thread. So this is a cotton thread. Okay, so this is a cotton thread. So now you have to explain this now. Okay, so this is the first option. As well have the second option, where you can have a spout. So this is a Eureka cane. Then where you put your measuring cylinder here like that. So this is now your cylinder. Okay. So this is a cylinder, of course, with calibrations here. Then the stone now is going to come here. Okay. And the amount of liquid is going to come here. And this is what we call the spout. Okay. So this is a Eureka cane. So you can pick any of the 2 options that we have there. Alright. So in the first one, I'm going to explain. So you get your measuring cylinder and pour a certain level of water. Now, you're going to record that volume of water as L1. So you are going to let that to be V1. So you say, get measuring cylinder, or so you put a certain level of liquid and you record it as V1. Alright? That's the first step that you do. Then secondly, what you're going to do is you get a stone, then tie it with a cotton thread. Then you displace it. So as you put it steadily so that you avoid the water from splashing. Alright? Because that may distort your results. So after you displace this into this one, then you are going to record now. In stage 3, you're going to take the volume after displacing the stone as V2. Now to find the volume of the stone, just say volume of rock, is going to be V2 minus V1. Take it for example, if your V1 was example, say 20 mils, and your V2 is now 35 mils. It means that the volume of your rock is going to be 35 minus 20. Of course, these are mils, and it's going to be 15 mils. And so this is the volume of a solid. We're going to put it in these units. Okay. So that's going to be your answer there. Okay, that is for this one. Now coming to this one, you will discover that you can use the Eureka cane as a substitute. So you get a Eureka cane, then you fill it with a liquid until it reaches the level of the spout here. Okay. Then secondly, you tie a stone, then with of course, a thread, a cotton thread. Then you displace it slowly. Okay. So after the displacement, you discover that this stone is going to displace the amount of water which is equal to its volume, and that amount of water is going to flow to this cylinder here. So when it comes to here, then so this one, there is no need of you calculating V1 and V2. So the exact volume that you're going to measure here, after the water that is going to be displaced from here coming this side, is going to be your VR. And this is also going to be 15 cubic centimeters. Okay. This is pretty easy, yeah? So no one should be able to fail this one. Now let's create space and see how we're going to solve B. Okay. How we're going to solve B. So this is A to explain why the volume of rock D, this one, can not be found with an ordinary measuring cylinder. Okay, so that one, just 1 mark for that one. So you understand to say, if you look at the results here, so if you compare 100, 200, and 448, that's the mass. Then you compare the volumes of 22, 42, and 80. Then you compare it to this and that. You will discover that this guy, rock D, is very huge. So it can never fit in the ordinary cylinder. So how do you explain that? You say rock D, okay, from its mass, which is this one, you can record in your explanation. So you can say rock D is relatively, because you're comparing, so you use the word relatively larger than other rocks. Therefore, it cannot fit in the ordinary measuring cylinder. Okay, so it cannot fit in the ordinary measuring cylinder. So therefore, you cannot use the measuring cylinder to measure the volume of this one, this rock D. Then calculate the density of rock A. So understand to say density is denoted by a Greek symbol called rho. Okay, so you understand, say density of what? Solid rock A, which is rho, okay, is given by mass of what? Rock A over the volume of rock A. And this information we've been given. So what do? We're going to get the mass of rock A, which is 101 grams, and then the volume to be 22 cubic centimeter. And this is going to give you what? Just try to punch on the calculator and see what is going to give us. What's the answer? Okay. Exactly. So you get 4.6 if you round that off. So what you're going to get is actually 4.6 after rounding it off. So you get this and also this. So this is it, grams. Then you're dividing. So you say slash this cubic centimeters. And that's the density for substance or rock A. Then part C says 3 of the rocks are made of the same material. State and explain which of the rocks is made out of a different material. So how do you determine that? So this is very easy. So one factor that will tell you to say, or one property of a substance that is going to tell you to say this substance is made of, these substances are made of the same material is the density. Okay, so for you to be able to understand here, say one of the rocks is made of a different material, you calculate the density for this one, and the density for this one, as well as this one. Then you compare. Okay, already we've calculated the density for A. So let's calculate for B. So you say rho B, then you say rho C and rho D. Let's see what we're going to be getting. Okay. So here again, you punch. So the mass is 202 over 44. And of course, this is going to give you the exact same answer. Okay, which is 4.6. Okay. Let's try C. So that's 448 divided by 80. What do you get? You get 5.6. Okay, which is different from what we've been getting. Now let's try the last parts. So 4508 divided by 978. So this is also giving you 4.6. Right. So you can understand to say this is a guy with a different, totally different what? Density. Therefore, it is the one that is made of a completely different material. Okay. So if you're enjoying the video, don't forget just to like. Also, you can share the video to people that can find it beneficial. And of course, don't forget to comment on that one video that you'd love us do together with you. Thank you. I always say peace.